The James Webb Space Telescope has revealed insights that are reshaping our entire picture of the cosmos. From the detection of ancient galaxies that appear far too early in history, to evidence hinting at liquid environments on distant exoplanets, every discovery has been more extraordinary than expected. But its most recent results go beyond anything astronomers had predicted. For the first time, combined data from Webb and the Hubble Space Telescope have thrown cosmology into turmoil. Something no longer fits within the framework we've relied on to describe the expansion of the universe. Many researchers are beginning to suspect that the problem lies not in error, but in our assumptions. If this proves true, it means the cosmos is not what we believed it to be, and that some unknown influence is shaping its very structure. For decades, scientists embraced a stable model of cosmic growth. The universe, they said, was expanding in a smooth, predictable way. That confidence was built on two pillars: measurements of Cepheid variable stars, stellar beacons whose flickering allowed astronomers to measure vast distances, and the faint afterglow of the Big Bang, the cosmic microwave background. Together, these tools produced one of the most important numbers in science, the Hubble constant, the rate at which the universe expands. For years, the model held. It suggested an age of about 13.7 billion years. But then inconsistencies appeared. Different techniques for measuring expansion gave different results. At first, these differences were dismissed as small errors. But Webb's unprecedented precision has revealed that the gap is no accident, it's a signal. When Webb's data were combined with Hubble's long-term observations, the result was undeniable. The universe's expansion is not uniform. Some regions expand faster than expected, others slower. The very rhythm of the cosmos shifts depending on where we look. What was once thought to be a minor discrepancy has now become one of the greatest puzzles in modern science. And that is only the beginning. Webb has also uncovered galaxies that should not exist according to our current understanding. One example, labeled ZFGS 7329, is larger than the Milky Way, yet it appeared just 700 million years after the Big Bang. Conventional theory argues that such a colossal structure could not have formed so soon. The universe should not have had enough time, enough matter, or the necessary scaffolding of dark matter to create it. And ZFGS 7329 is not unique. Webb has revealed swarms of early galaxies that appear well-formed and massive in an era when the universe should have been a turbulent cloud of gas. Even more astonishing, Webb has observed supermassive black holes, millions or billions of times the mass of our Sun, existing in the same early period. Their very presence challenges the physics of how black holes are thought to grow. These findings raise an unsettling possibility. Perhaps our estimate of the universe's age is wrong. Astrophysicist Rajendra Gupta has suggested a bold idea, that the universe may not be 13.7 billion years old, but more than 26 billion. His argument is that light from faraway galaxies could be deceiving us. Over immense distances, the stretching of space might distort that light in ways we haven't fully accounted for, making us underestimate its journey through time. Gupta goes further, proposing that what we call empty space is not truly empty at all, but filled with hidden structures of matter and energy. If correct, this could reduce or even remove the need for dark matter and dark energy, the mysterious pillars of modern physics. This idea is controversial. Some dismiss it as too radical, while others see it as a potential solution to the long-standing Hubble tension. If Gupta is right, the universe may be far older and stranger than we imagined. But Webb's observations raise another question. If our universe isn't behaving as expected, what is influence? For centuries we believed the cosmos was a steady, predictable stage, a vast, quiet theater in which galaxies drift apart like dust motes in sunlight. Then came a new kind of eye, the James Webb Space Telescope. In a few short years it has given us images and measurements that unsettle that calm. Piece by piece, the story we thought we knew is changing. Beat. Webb first surprised us with the unexpected youth of ancient giants. Galaxies that appear mature and massive when the universe was barely out of infancy. These early structures challenge the timelines astronomers had long accepted. If they formed so quickly, our ideas about how matter clumps and grows must change. Beat, swell of orchestral underscore. More puzzling still are the phantom ripples. Webb has traced across deep space, regions where light and matter curve and streak in ways we cannot yet explain. Scientists have given one of these strange regions a working name, the phantom formation. Light passing through there arrives altered, bent not only by gravity but by something else, something that distorts space-time as if shaped by an invisible hand. Beat, two bold possibilities rise from these anomalies. Some theorists say we could be seeing the subtle influence of other universes, neighboring realities tugging at ours, leaving fingerprints on how space itself stretches. Others suggest we may be glimpsing the first hints of a new kind of energy, a field woven into the fabric of space that changes how matter and light behave. Beat, either idea would rewrite textbooks. If parallel universes can interact, then the cosmos we call home is not isolated but a single page in a much larger story. If a new field exists, then the forces we thought complete are only half the tale. Softening, then there are the signals, emissions from empty regions of space that match no catalogued object. They are neither stars nor galaxies, nor the familiar signatures of black holes. Their spectra and rhythms are alien. Some researchers propose exotic, hypothetical objects built from particles we have never detected. Others, more cautiously, say we must keep an open mind. In science, unexplained does not equal impossible. Beat, and still a third, stranger thought lingers in the halls of theory. Could any of these signals be artificial? The suggestion is not a conclusion, only a question. A doorway opened by data that resists all natural explanations. To suggest intelligence is to invite extraordinary scrutiny, and the scientific method demands patience and rigor. For now, the idea is a whisper, not a verdict. Beat, increase tempo slightly. Webb has also turned a harsh light on the long-standing problem known as the Hubble tension, the mismatch between different methods of measuring the universe's expansion. One set of tools, rooted in nearby stars and supernovae, gives one value. Another, reading the newborn universe in the cosmic microwave background, gives another. Webb's measurements sharpen the conflict. The universe's expansion may not be uniform. Some regions race ahead, others lag behind. The universe's heartbeat, it seems, varies with location. Beat. A provocative response to this puzzle comes from a small group of researchers who argue that our cosmic calendar might be wrong. If light is stretched or altered in unexpected ways over vast distances, then our distance markers, the lighthouses we use to measure time and space, could be misleading. One daring proposal even places the universe's age far beyond our standard estimate, suggesting a chronology much older than the one taught in classrooms. Softening, not everyone accepts these ideas. Many physicists urge caution. Radical claims require radical evidence. Yet history shows us that when careful observation breaks expectation, the result is often an advance in understanding. Sometimes a small correction, sometimes a revolution. Beat, so what are we to believe? That galaxies sprouted too early? That black holes ballooned faster than our models allow? That dark matter and dark energy, the twin pillars of modern cosmology, may be shadows of a deeper reality? These are the questions Webb hands us, not as answers but as invitations. Beat. Consider the possibility that the universe carries scars. relics of collisions with other realities, or the imprint of a new field crossing its expanse. Imagine a cosmos where space itself is laced with hidden structures that shape how galaxies form and how light travels. Imagine, too, the humbling thought that our models are tools, not truths, maps that will be redrawn when the landscape demands it. Beat, quiet, Webb's mirrors are still new, and its mission has only just begun. Each observation is a probe into the unknown, and every anomaly is a clue. Some mysteries will dissolve under scrutiny. Others will deepen, opening new chapters in physics and cosmology.